Today's topic is angle relationships in circles. It's going to be crucial that you go over your notes from the previous sections. The math is not hard. A lot of times we're adding things, dividing by 2, subtracting things, and so forth. 180 minus. So the math is pretty easy. It's keeping it all straight that's tough. So I would highly recommend that you go through and consolidate your notes, rewrite your notes, revisit your notes. Okay? This is going to be on your thing. Yes, on the right-hand side is where we're at. Okay? So this first theorem is called tangent and intersected chord theorem. You don't need to know the name. What I want you to know is the relationship between these things. Sorry. So we have a tangent. We have the relays going out, and they haven't fixed it yet. So we have a tangent that is intersecting a chord. Okay? If a tangent and a chord intersect at a point on the chord, on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So each of these angles formed is 1/2 the measure of the intercepted arc. The red arc divided by 2 gets us the angle 1. The blue arc divided by 2 would get us angle 2. Okay. So if a tangent and a chord intersect at a point on a circle, the measure of the angle formed is 1/2 of its intercepted arc. Take the arc divided by 2, you've got the angle. Take the angle times 2, you get the arc back. Okay? So here comes the first example. Not yet. Okay, we're only on the right-hand side of your sheet right now. Okay? So angle A, the angle 1 at A is 1/2 of minor arc AB. And the measure of angle 2 is 1/2 of that major arc BCA. Okay? So here are 2 examples. We have a chord and a tangent that are intersecting, and it's forming 2 angles, one obtuse angle, one acute angle. Angle 1 is this obtuse angle, and its intercepted arc is this major arc AB. We don't have a third point to call it, to name it properly. So if the arc has a measure of 240 degrees, what do you think the measure of angle 1 is? Is it exactly equal to? 120, because it's 1/2 of the intercepted arc. So angle 1 will be equal to 240 divided by 2, 120 degrees. Okay. Take the arc divided by 2 to get the angle. That's all you do. So the second one, we have a 155-degree angle here at L. So the angle is 155 degrees. This major arc has to have a measure of what? How do we find it? Double it. We double 155. This time we want the arc, so we double the angle, 155 times 2, and we get 310 degrees. Okay. If you have the angle, double it to get the arc. If you have the arc, yep, that whole thing, that red arc, is 310 degrees. Okay. That happened when a tangent and a chord, or a tangent and a secant, intersected. Okay. Now, this is not on your notes sheet, but these kind of make sense. there are three possible ways that two non-parallel lines can intersect a circle. One of them is actually when they intersect on the circle. That point of intersection is actually on the circle. Okay, it's not on your sheet. The second one is if they intersect inside the circle, and the third one is if they intersect outside the circle. So we just talked about what happens when they intersect on the circle and it's a chord with a tangent. Okay, so let's look at the next example or next theorem here and see what happens when angles intersect inside the circle, are created inside the circle. If two chords intersect inside the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by that angle and its vertical angle. So if two chords intersect inside a circle, then each angle is 1/2 the sum of the measures of the arcs that it intercepts. When you think of 1/2 the sum of those arcs, think about averaging them up. This angle 1 is created by two chords intersecting inside the circle. They're not central angles because they didn't intersect at the center. Their vertex is not the center. But angle 1 has two arcs that it intercepts, DC and AB. So angle 1 is half of the sum of arc DC and AB. Angle 2 is half of the sum of arcs BC and AD. Okay. So add the arcs, divide by 2, and you get each of those vertical angles. They're intercepted angles. Okay. Should be on your notes. You should be at, oh, that one's not? Yeah, it should be. If two chords intersect inside of a circle. Okay, yeah, the picture itself is not the formal definition. I didn't have enough room for all of that, so I just gave you the examples. Okay. So how do we do this problem? We have arc AB that has a measure of y degrees. And we have arc DC that has a measure of 95 degrees. Okay. So an angle and its vertical angle would be half the sum of these two guys. Okay. So we would want to add them up and divide by 2. The problem is we want to add the arcs and divide by 2. So y plus 95 divided by 2 will be equal to one of those angles that it makes. Okay, but which angle is it? It's this angle right here. Okay. These two arcs are intercepted by these two angles, right? So they're being tricky when they give you 102 for this angle, aren't they? This is also 102. So you would say 204 is this one. Okay, the problem is 102 is this guy, okay? And this would be, let's call this A and B. It's going to be equal to A plus B divided by 2. Okay, but 95 goes with these two. Okay, so if this is 102, can we find this angle? They're supplementary. Okay? So what's 180 minus 102? So this is 78. So if this angle is 78 degrees, then erase that so it looks right. Okay, this is 78 degrees, right? Then y plus 95 divided by 2 should be equal to 78 degrees. So they're trying to trick you by making you think that 102 is going to be equal to 90 plus 95, or y plus 95 divided by 2. But it has to be directly across from it. Nope, we say 102 minus, subtracted from 180 gets me 78. Okay, now ignore the 102 and everything else. Now we know, so getting rid of all of this extra stuff. Okay, so if this is 78 degrees, because they are supplementary, then this angle should be equal to the sum of the arcs divided by 2. Y plus 95 divided by 2, okay? Add the arcs, divide by 2, it's equal to the angle. Not quite, because what's happening here is we're dividing by 2 and we want to get the y by itself. Yes, sir? Yes. We have to get rid of the dividing by 2. What's the opposite of division? Multiplication. But if we multiply the left side by 2, what do we have to do to the right side? Same thing. So y plus 95 is 156. What do we do to get the y by itself? Subtract 95. And y becomes 51 degrees. No, 61 degrees. Thank you. Okay, so y is 61 degrees. Because if we take 61 plus 95 and divide that by 2, we get 78. Okay, so they made it more challenging by giving you this angle, not the one that we needed to be able to work the formula. Okay, what questions do you have on this one? Okay, all right, next slide then talks about our next property, and that's about deals with angles that are created outside the circle. So there are 3 ways that we can create angles outside the circle. If we have a secant and a tangent intersecting, we'll get an angle outside the circle. If we have 2 tangents intersecting, we'll get an angle outside the circle. And if we have 2 secants intersecting, we'll get an angle outside the circle. The good news is, doesn't matter what happens to make those angles be created outside the circle. If you want the angle, you're going to take 1/2 the difference of the arcs. To find the angle, take 1/2 the difference of the arcs. Inside the circle, find the angle, you add the arcs, divide by 2. Outside the circle, if you want the angle, you subtract the arcs and divide by 2. Silly way to remember it is bark minus lark divided by 2. What do you think bark stands for? Nobody's going to bite and say the sound a dog makes? And lark is a bird, right? Okay, it's what it sounds like, doesn't it? But how did I spell it? Bark with a C, right? So what do you think bark stands for? The arc. Which one? Which kind of arc? The big arc minus the little arc divided by 2. Okay, So we're going to take the big arc minus the little arc divided by 2 to get the angle. Okay, so let's look at an example. All right, so here's our example. Tangent and a secant intersect to make an angle outside the circle. Okay, I want to know that angle, so I take, bark minus lark divided by 2. 178 minus 76 divided by 2. 102 divided by 2, 51 degrees. Okay, bark minus lark, big arc minus little arc divided by 2. Okay, how about the next one? Now I know the angle, 100 minus x divided by 2 equals 35, right? Bark minus lark divided by 2 equals the angle. Big arc minus little arc divided by 2 gets you the angle. 100 minus x is being divided by 2. How do I handle that? You could take 100 divided by 2 minus x divided by 2 equals 35. Or, let's get rid of the 2. Multiply the 2 by both sides. That cancels that one. And we get 100 minus x equals 70. And then negative x will be negative 30, right? So x will be a positive 30. So you should always get positive angles. If you get a negative angle, you've done something wrong. Okay. Bark minus lark divided by 2. So far, so good? What questions do you have on this slide? All right, next slide then talks about a circumscribed angle. Okay. Yesterday we talked about polygons that were inscribed in a circle, and the circle was circumscribed around that polygon or that quadrilateral. Today we have circumscribed angles, which means that these two tangents are forming a enclosure around that circle. Okay? The circle's completely within those two angles, or those two tangents, that angle. So a circumscribed angle is an angle whose sides are tangent to the circle. Or as I stated in your notes sheet, if a circumscribed angle has sides that are tangents. So now we're in the box of our notes. The measure of a circumscribed angle is equal to 180 minus the measure of its central angle that it intercepts. Okay, so that's one way to look at it. There's a lot of vocabulary there. Okay, so what they're saying is the measure of this angle down here at D is going to be 180 minus this angle here at C. And let me show you why. What kind of a figure do I get if I look at this figure? A kite. Okay, specialized quadrilateral, right? What do we know about the tangent, a radius that is tangent to the circle at the point of tangency? Good. The arc is going to be double that angle. And what kind of angle do we have here? A radius to the point of tangency is perpendicular to the point of tangency, isn't it? So we have a 90-degree angle here, right? A 90-degree angle here. So in a quadrilateral, how many degrees are there in the whole quadrilateral? It does. Or some myopic drawing or whatever from eyesights and. So, how many degrees in a quadrilateral? 360. So 360 in a four-sided figure. We have two angles that are 90 each. That's 180, right? So how much is left for these guys? 180. So it makes sense that these two have to add up to 180. Okay? So let's look at an example with actual numbers in it. We have two tangents forming an angle. The angle is circumscribed around the circle. From the center to the point of tangency, that radius is going to be perpendicular to that tangent. So since this is 180, we have 180 left for these two. What's 180 minus 124? 56. So 180 minus 124, 56. So x is 56 degrees. Make sense? Convinced? Okay. This one looks a little different. This time we know the angle, and we want to find out what x is. What kind of angle is x? Acute. I agree with acute most likely. But as far as our vocab for this chapter is concerned, what kind of an angle is that? This is a minor arc. Maybe a right angle, we're not sure. It looks like it could be. We're not sure yet. But what kind? We talked about two kinds of angles yesterday. One of them that you knew from before, a central angle. What was the other one? Inscribed angle. Good job, Will. So an inscribed angle is equal to what? Its intercepted arc. Half. Okay. An inscribed angle is half of its arc. So if this is x, the arc would be 2x, right? Make sense? Okay. And let's draw this central angle by drawing our two radii from the center to those points of tangency. Okay. When this is 2x, this intercepted arc is 2x, that means our central angle is also 2x. The central angle is equal to the arc that it intercepts. So this is 2x. Okay. A radius to a point of tangency is going to be perpendicular, right? So if this is 2x and this is 42, what do they have to add up to? x plus 42 have to add up to, we've got 90 already, right? And 90 more. That's 180 taken up. So if 180 is gone from our 360, there has to be 180 left. Okay? No. I want to make sure everybody understands. Okay? So over here we said that radius to the point of tangency is perpendicular. Okay? So in a quadrilateral, in a four-sided figure, we have a total of 360 degrees in that lovely kite. Okay? Give me a second. Okay? So these two add up to 180. 90 and 90 is 180. That means we have 180 left for these guys. Okay? So 180 minus 124 gets us 56. Okay, same idea here, but instead of giving us that central angle, they gave us an inscribed angle. Okay? And yesterday we learned that if we have an inscribed angle, then it's going to be half of the measure of its intercepted arc. Okay? This guy's half as big as the arc it intercepts. So this is an inscribed angle. The arc that it intercepts has to be a total of 2x. Because the angle is x, we double it to get the arc. Does that make sense, Maddie? Okay. Yesterday we learned that an inscribed angle is half the intercepted arc. So the arc has to be twice as big as the angle. Not making sense, Jake? It does? You're okay? Okay. So if this is 2x, the central angle also has to be 2x. Central angles and their intercepted arcs are the same. Okay. So now 90 and 90 are gone from my 360. That leaves 180 left. So these two should add up to 180. Okay. So let's take away 42. $138, right? And divide by 2. Okay. So it all builds. You have to know the inscribed angles. You have to know your major arcs, your minor arcs, central angles. The radius to the point of tangency is perpendicular to the tangent. All of those things. Study your notes. And hopefully you'll at some point consolidate your notes all to one sheet by rewriting them. That helps you revisit. Do I know this? Is it important? How much do I remember? And so forth. By rewriting those, that will help you. I could. I'm going to try. It's one of my weekend projects. Okay, it'll be small. It'll be tiny. It won't be nearly as big as these are. Okay. Everybody good? At least enough to practice and see what you know. So then Monday's no school. Tuesday, we'll go back and revisit 10.4 and 10.5, the inscribed angles and these, so that we have plenty of practice on them. All right, assignment is on the board. And we're ready to practice.